Next, we are looking at exercises similar to the principal exercises. This is under section 2.1 and it's number 40a. It says find a system of two linear equations in the variables x1, x2, and x3 whose solution set is given by the parametric equations x1 equals t, x2 equals 1 plus t, and x3 equals 2 minus t. So what I'm going to do here is I'm kind of just going to work backwards. So I'm firstly writing down my solution because it's given to me. So I'm just going to write down my solution in vector form. So just so that I can see it. So it's x1, x2, x3 equals, and then they say x1 is t, x2 is 1 plus t, and x3 is 2 minus t. So what we can see here is that it seems as though x1 is our free variable since it was set equal to a parameter t, and then x2 and x3 are both leading variables and they are written in terms of our free variable, which is x1, which is equal to t. So what I'm going to do is they ask me to find a system of two linear equations, right? So all I'm going to do is from here, since I have x2 equals 1 plus t, and I have that t equals x1, it means that x2 equals 1 plus x1. And I also have x3 equals 2 minus t, but t is x1. So it is 2 minus x1. So in other words, what we have is my first equation. I'm just going to write all of my variables on the left. So I have minus x1 plus x2 equals 1. So this is my first equation. And then I'm going to do the same for my second equation. I'm going to write all of my variables on the left. So I have x1 plus x3 equals 2. And there I have my system of two equations, and we work backwards from the solution to get the system. The final problem is under section 2.2 and it's number 49, and it says determine whether the lines x equals p plus su and x equals q plus tv intersect, and if they do, find their point of intersection. Right, so for two lines to intersect, it means that we have to set their right hand sides equal to each other. So we have to have p plus su equals q plus tv. Right, so now I'm just going to write it in vector form. So I'm going to write in all of my vectors. So I have 3, 1, 0 plus s multiplied by u, which is 1, 0, 1 equals q, which is minus 1, 1, minus 1 plus t multiplied by v, which is 2, 3, 1. Now I'm just going to write it as sets of equations. So I have 3 plus s equals minus 1 plus 2t, 1, and then it's s times 0 equals 1 plus 3t, and then I have 0 plus s, don't need that plus there, equals minus 1 plus t. So all I did was I just took the 3 and then I multiplied the s by the 1, minus 1 multiplied by the t by the 2 to get my first equation. Then for the second one, took the 1, s multiplied by 0, 1 plus t multiplied by 3, and then for my third equation, I took 0 plus 1 multiplied by s equals minus 1 plus t multiplied by 1. Right, so then I get those three equations. Now, what we want to do is the next step, I'm simply going to write it with all of my variables on the left-hand side and all of my constants on the right-hand side. So for my first one, I'm going to have s minus 2t equals minus 4. For my next one, I'm going to have 3t equals 0. And then for my next one, I'm going to have s minus t equals minus 1. Right. So what we basically want to do here is we want to find the values for s and t, which are the parameters of the two respective lines, and we want to find those values for s and t where the two lines intersect. That's why we set the two lines equal to each other. And if we can now solve s and t, that means that the two lines do intersect, and they intersect where s and t equals whichever values we get by solving this system. So I'm going to write this in an augmented matrix. So I have 1 minus 2 minus 4, then I have 0, 3, 0, and then I have 0, minus 1, minus 1. Right, so my first column is already the way that I want it. I have a leading one and I have all zeros below it. Now I have my second leading variable. I'm going to take that as my 3. I'm just going to change the 3 into a 1 so that it's easier to work with. So I'm just going to multiply row 2 by a third. So then I have 1 minus 2 minus 4, 0, 1, 0, and 0 minus 1 minus 1. And then I want to create a 0 below my second variable, which is now also a 1. So I'm going to say row 3 plus row 2. So row 3 plus row 2 to give me the new row 2. And so then I have 0 minus 2 minus 4, 0, 1, 0, 0, 0, minus 1. So in our last row, we definitely have a problem, because what this will mean is it means that 0 equals minus 1, but that's not possible. That means that our system has no solution, and therefore there is no intersection of the lines. This is the end of this week's video.